Welcome to PreMath. In this video, we have got this isosceles trapezoid fully inscribed in a semicircle, as you can see in this given diagram, such that one of the side lengths of this trapezoid is on the diameter of this semicircle, and the diameter of this semicircle is 8 units. And moreover, these side lengths BC, CD, and AD of this trapezoid are equal in length. And furthermore, these points A, B, C, and D lie on the very same semicircle. And now our task is to calculate the perimeter of this trapezoid ABCD. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And now let's recall the definition of a cyclic quadrilateral. If all the vertices of the quadrilateral lie on the very same circle, and we can see all these points A, B, C, and D lie on the very same semicircle. So no wonder this trapezoid is a cyclic quadrilateral. And now let's assume that this side length CD is x units, and since all these side lengths are equal in length, so therefore this side length is going to be x and this side length is going to be x units as well. And now our task is to find the value of x, and since we are interested in calculating the perimeter of this trapezoid ABCD, in other words, the sum of all these four side lengths of this trapezoid, 8 plus x plus x plus x is going to be the perimeter of this trapezoid. And in this next step, I am going to connect these two vertices B and D, as you can see in this next step. And now let's recall the Thales theorem. According to this theorem, if A, B, and D are three distinct points on a very same circle, and AB line is the diameter, then the angle ADB is a right angle. So no wonder this angle ADB is going to be a 90-degree angle, since these vertices A, B, and D lie on the very same semicircle, and AB is indeed the diameter. And now let's focus on this right triangle ADB, whose side lengths are 8 and x. And now let's assume this side BD is y, and we are going to use the Pythagorean theorem on this triangle. And here's our Pythagorean theorem: a square plus b square equal to c square. And in our case, our hypotenuse is 8, whereas our two other legs are x and y. Let's go ahead and fill in the blanks in this Pythagorean formula. So we got x square plus y square equal to 8 square. So this could be written as x square plus y square equal to 64. And now I am going to move this x square on the other side. So therefore we are ended up with y square equal to 64 minus x square. And now I'm going to undo this square by taking a square root on both sides. So therefore our y value turns out to be positive the square root of 64 minus x square. So therefore our this side length BD turns out to be square root of 64 minus x square. Now in this next step, I am going to connect these vertices A and C as well, as you can see in this next step. Then according to the Thales theorem, this angle ACB is going to be 90-degree angle as well. And since we are dealing with this isosceles trapezoid, in other words, this leg equals to this leg, so therefore this diagonal BD is going to be equal to this diagonal AC. So therefore we conclude the length of this diagonal AC is going to be square root of 64 minus x square as well. So therefore we can see that our both diagonals BD and AC are square root of 64 minus x square each. And now let's recall the Ptolemy's theorem. According to this theorem, we got this cyclic quadrilateral ABCD in this diagram, where we got these side lengths AB, CD, AD and BC, along with these diagonals AC and BD. And according to Ptolemy's theorem, 8B side length times side length CD plus the side length AD times BC is going to be equal to the product of these two diagonals AC and BD. And in our case, our side lengths are x8, x and x, and our two diagonals are square root of 64 minus x square each. So let's go ahead and fill in the blanks in this formula. Our AB length is 8, our CD length is x, plus our AD length is x, and BC length is x as well, equal to our AC length is square root of 64 minus x square times BD length is 64 minus x square as well. Let's simplify. So 8 times x is going to give us 8x plus x times x is going to give us x square, equal to, on the right hand side, when we multiply both of these, we are going to remove this radical sign. So we are going to get 64 minus x square. And now I'm going to move all these terms to the left hand sides. So therefore we can write 8x plus x square minus 64 plus x square equal to 0. Let's combine the like terms. So we are going to have a 2x square plus 8x minus 64 equal to 0. And now I'm going to divide each and every term by 2 to make our job simple. So therefore we are ended up with this quadratic equation x square plus 4x minus 32 equal to 0. And we can easily find its factors. X minus 4 times x plus 8 is going to be equal to 0. Since both factors are equal to 0, I can separate them. I can write x minus 4 equal to 0, and the other factor is going to be x plus 8 equal to 0 as well. For this first equation, our x value is going to be positive 4. For this second equation, x is going to be equal to negative 8. And now we can see x equal to negative value is not possible, since x is one of our side lengths. So therefore we are going to reject this x equal to negative 8 value, and we are going to accept x equal to positive 4 value. So thus our x value turns out to be 4 units. In other words, this side is 4, this side is 4, and this side is 4 units as well. And here's our final step. Now we are going to find the perimeter of this trapezoid ABCD. And the perimeter is going to be the sum of these side lengths 8 plus 4 plus 4 plus 4 of this trapezoid ABCD. So therefore we can write down 8 plus 4 plus 4 plus 4 as well. And if we add all these numbers on the right hand side, that is going to give us 20 units. So thus, after all the calculations and manipulations, the perimeter of this trapezoid ABCD turns out to be 20 units. And that's our final answer. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.